Our whole industrial world, it runs on these massive, complex machines. But what happens when this unseen enemy, this grime and scale and buildup, starts to choke the whole system from the inside out? We're about to dive into the super high-stakes world of industrial chemical cleaning, where chemistry is pretty much the only thing standing between a smooth operation and total breakdown. So when we picture factories or power plants, we think of production, right? But inside, there's this constant hidden battle being fought against grime. But what does that gunk and buildup actually cost? I mean, is it just about things looking dirty, or is there something way, way bigger going on here?
Well, the cost is absolutely staggering. That buildup, that contamination, it's not just ugly. It's a silent killer of efficiency, forcing equipment to burn way more fuel just to do its job. And even worse, it creates these potentially catastrophic safety hazards. In this world, clean isn't just a nice to have, it is absolutely mission critical.
Okay, so first up, let's get a really good look at the enemy, this unseen grime problem. And to fight this grime, engineers don't just use soap and water. No way. They deploy a really sophisticated chemist toolkit. It's not one magic bullet, but a whole arsenal of specialized chemical solutions. So what's in this toolkit? Well, it really boils down to 4 core methods. You've got your descaler, which is acid-based for all that mineral buildup. Then there's the degreaser, which is alkaline for oily messes. You've got a specialized dissolver for the really tough stuff. And finally, a really precise tool we'll call the gentle grabber. All right, let's dive in and see how the experts actually match these chemical tools to the very specific kind of grime they're up against. It's pretty fascinating. First up, acid cleaning. Okay, I want you to imagine that hard, chalky lime scale you get in a kettle. Now, picture that on a massive scale, coating the inside of giant industrial boilers. Acid cleaning is basically the chemical powerhouse that's designed to just dissolve that rock-hard mineral buildup. But here's where the expertise comes in, because the choice of acid is critical. You might use something really powerful, but also corrosive, like hydrochloric acid for tough scale on steel. But for more sensitive metals, you might go with a gentler organic acid, like citric, to avoid damage. The goal is always the same: dissolve the scale, not the multi-million-dollar equipment.
So, next in the toolkit is alkaline cleaning. Now, if acid cleaning dissolves mineral rock, alkaline cleaning goes after its total opposite, that greasy, oily, organic gunk. It uses powerful bases like caustic soda to basically turn that sticky residue into a soap-like substance that can be washed away.
Its number one job is degreasing, and it's often the most important first step. I mean, think about it. You can't dissolve mineral scale if it's hiding under a thick layer of grease, right? Alkaline cleaning is like the industrial-strength primer that clears the way for other treatments to actually work. So this little table kind of sums up the fundamental difference perfectly. Acid cleaning is your rock dissolver for mineral scale, while alkaline cleaning is the grease cutter for all the organic stuff. They're really 2 sides of the same coin, and a lot of the time they're used one after the other to tackle complex, layered contamination. But what happens when the mess isn't mineral-based or just simple grease? For those really tough, stubborn hydrocarbon compounds, like heavy crude oil or waxes, you have to call in a specialist, solvent cleaning. The whole point here is to dissolve these incredibly sticky substances that pretty much nothing else can touch. But what's really important to know is the trend in the industry. There's this massive shift away from the harsh, traditional solvents towards greener, safer alternatives that work just as well but have a much smaller environmental footprint. And finally, we get to the most precise tool in the kit, Solvent Cleaning. Now this is cool. Instead of just brutally dissolving deposits with strong acids, this method is, well, it's more elegant. Imagine microscopic claws, or L.L.C, that are designed to specifically target metal ions, like the iron in rust. Gently grab onto them and just carry them away. This gentle approach has huge benefits. It dramatically reduces the risk of corrosion, which can extend the life of these incredibly expensive assets. And it also produces a much more stable, less hazardous waste stream, which makes it a smarter and safer choice for both the equipment and for the environment. So there we have it, our 4 main tools. But knowing what the tools do is one thing. The real expertise, the real magic, isn't in the tools themselves. It's in the strategy. It's about creating a custom-fit battle plan for every single unique cleaning challenge.
This idea right here is just so important. This isn't about picking a chemical off a shelf. It's more like a forensic investigation. You have to analyze the specific gunk you're dealing with, understand the metals the equipment is made of, and make sure the whole strategy lines up with what the plant needs to achieve. And this is exactly how the experts in the field do it. They don't use a standard playbook. Instead, they assess every single situation individually. They select the perfect combination of methods to get the best possible clean with the least amount of downtime and the smallest possible environmental footprint.
But this battle against grime is far from over. The chemistry behind it is constantly evolving. So what's next? What does the future of industrial cleaning even look like?
Well, the direction is pretty clear. The future isn't about finding even harsher chemicals. It's about getting smarter, safer, and a whole lot more sustainable. It's about using things like biology and even nanotechnology to get a better clean. And the innovation here is just remarkable. We're seeing enzyme-based cleaners that literally digest specific types of grime. Nanotechnology is creating solutions that can get in and break down contaminants at a molecular level. And all these new biodegradable formulas are being developed that can clean like crazy and then safely neutralize themselves, leaving almost no trace behind.
Which kind of leaves us with a final thought to chew on. We spend so much time celebrating the building of new things, right? But as our world gets more and more complex, maybe the most critical breakthroughs won't be in what we create, but in the science of how we maintain it all. That hidden, unseen work that just keeps everything running.